Hello everyone, I'm Professor Diwa. Welcome to another math video. In this video, I'm going to go over adding and subtracting rational expressions. Our objectives are to add or subtract rational expressions with the same denominator, find the least common denominator, or LCD, of two or more rational expressions, add or subtract rational expressions with different denominators. Alright, so let's get started. Adding or subtracting rational expressions with a common denominator. To add or subtract rational expressions with a common denominator, add or subtract the numerators and write the sum or difference over the common denominator. We have p divided by q plus r divided by q is equal to p plus r divided by q, and p divided by q minus r divided by q is equal to p minus r divided by q. For example number 1, add or subtract. For part A, we have 3 plus x divided by x plus 4 divided by x. To add together these two rational expressions, we just add together the numerators and put it over the common denominator. We get 3 plus x plus 4 over x. Combining like terms on the numerator, we get 3 plus 4 is 7. The final result is x plus 7 divided by x. Moving on to part B, we have 4x plus 5 divided by x plus 3 minus x minus 2 divided by x plus 3. First, we combine everything under one fraction. We get 4x plus 5 minus parentheses x minus 2 divided by x plus 3. Next, we distribute the negative sign inside the parentheses to the x and the minus 2. The result is 4x plus 5 minus x plus 2 divided by x plus 3. Next, we combine like terms on the numerator. We have 4x minus x is 3x. We have 5 plus 2 is 7. The final result is 3x plus 7 divided by x plus 3. Next, we have a practice problem, add or subtract. For part A, we have a minus 5b divided by a plus b plus a plus 7b divided by a plus b. For part B, we have 1 divided by 4a squared b minus 5 divided by 4a squared b. Alright, so go ahead and pause the video, try out these problems, and then check back with the video to see the answers. Alright, so let's go ahead and start with part A. First, we combine everything under one fraction. We get a minus 5b plus a plus 7b all divided by a plus b. From here, we combine like terms on the numerator. A plus a is 2a, minus 5b plus 7b is 2b. The result is 2a plus 2b over a plus b. Next, we could factor out a 2 from the 2a plus 2b. The result is 2 times parentheses a plus b over a plus b. Next, we cancel out the common factors of a plus b. The final result is 2. Moving on to part B, we combine everything under one fraction. We get 1 minus 5 over 4a squared b. Simplifying the numerator, 1 minus 5 is negative 4. The result is negative 4 divided by 4a squared b. Next, we cancel out our common factors of 4. The final result is negative 1 divided by a squared b. Next, we have example number 2, add or subtract. We have 4x squared minus 5xy divided by x squared minus y squared plus 2xy minus y squared divided by x squared minus y squared. First, we combine everything under one fraction. We get 4x squared minus 5xy plus 2xy minus y squared all over x squared minus y squared. Next, we combine like terms with the negative 5xy and the plus 2xy. We get negative 3xy. Also on the denominator, x squared minus y squared can be factored as a difference of squares. So the result is 4x squared minus 3xy minus y squared divided by parentheses x minus y times parentheses x plus y. Next, we can factor the numerator using the star method. The result is parentheses 4x plus y times parentheses x minus y divided by parentheses x minus y times parentheses x plus y. Next, we could cancel out our common factors of the x minus y. The final result is 4x plus y divided by x plus y. Next, we have a practice problem, add or subtract. We have 5 minus 7x divided by x squared minus 3x minus 10 plus 8x minus 3 divided by x squared minus 3x minus 10. Alright, so go ahead and pause the video, try out this problem, and then check back with the video to see the solutions. Alright, so let's go over the practice problem. First, we combine everything under one fraction. We get 5 minus 7x plus 8x minus 3 over x squared minus 3x minus 10. Next, we combine like terms on the numerator, and we factor the denominator. The result is x plus 2 divided by parentheses x minus 5 times parentheses x plus 2. From here, we could cancel out our common factors of the x plus 2. We get our final result, which is 1 divided by x minus 5. Next, we're going to go over finding the least common denominator, or LCD. Step number 1, factor each denominator completely. Step number 2, the LCD is the product of all unique factors, each raised to a power equal to the greatest number of times that the factor appears in any one factor denominator. In example number 3, find the LCD of each pair of polynomials. For part A, we have 5 divided by 21xy squared and 3z divided by 3x squared y cubed. To find the LCD, first we check if the denominator is factored completely, which it is. Next, we look at the coefficients. We have 21 and 3. We take the larger coefficient 21 and see if 21 is divisible by 3. Because 3 divides evenly into 21, 21 will be part of our LCD. However, if 3 did not divide evenly into 21, then you take the next multiple of 21, which is 42, and see if 3 divides evenly into 42. And if it didn't divide evenly into 42, then you check the next multiple of 21, and you keep repeating that process until you find a multiple of 21 that is divisible by 3. Again, 21 is divisible by 3, so we use 21 as part of our LCD. Next, we move on to the variable terms. Starting with x, we have x and we have x squared. We take the x variable with the higher exponent, so x squared is part of our LCD. Next, we move on to the y variable. We have y squared and y cubed. Y cubed is the larger exponent, so we use y cubed as part of our LCD. For the final answer, we just take the product of all of the terms we found for our LCD. We have 21x squared y cubed is the LCD. Moving on to part B, we have 1 divided by x squared plus x minus 12 and 9 divided by x squared minus 16. The first step is factoring the denominators. So we could factor x squared plus x minus 12 using the x method. The result is parentheses x plus 4 times parentheses x minus 3. For the x squared minus 16, we could factor that as a difference of squares. We get parentheses x plus 4 times parentheses x minus 4. The next step is taking all the unique factors and including them in our LCD. So from the first fraction, we can include the x plus 4 and the x minus 3 as part of our LCD. From the second fraction, we already have an x plus 4, so we don't include it again, but we don't have an x minus 4, so we include the x minus 4 as part of our LCD. Next, we just take the product of all the terms we found for our LCD. Our final answer is parentheses x plus 4 times parentheses x minus 3 times parentheses x minus 4. Next, we have a practice problem. Find the LCD of each pair of polynomials. For part A, we have 1 divided by 8x squared and 1 divided by 12x to the 5th power. For part B, we have 7 divided by x squared minus x minus 2, and 3 divided by x squared minus 9. Alright, so go ahead and pause the video, find the LCD for each pair of polynomials, and then check back with the video to see the solutions. Alright, so let's start with part A. To find the LCD, we take a look at the coefficients first. We have 8 and 12. We start with the larger coefficient 12 and see if 8 divides evenly into 12. Since 8 cannot go evenly into 12, we use the next multiple of 12, which is 24. Since 8 divides evenly into 24, 24 will be part of our LCD. Next, we move on to the x variable. We have x squared and x to the 5th power. We take the one with the larger exponent, so x to the 5th power is part of our LCD. Next, we just take the product of all the terms we found for our LCD, so we have 24x to the 5th power. Moving on to part B, we first factor each of the denominators. X squared minus x minus 2 can be factored using the x method. The result is parentheses x minus 2 times parentheses x plus 1. Factoring x squared minus 9 as a difference of squares, we get parentheses x minus 3 times parentheses x plus 3. Next, we include all of the unique factors from each denominator. So from the first denominator, we include the x minus 2 and the x plus 1. From the second denominator, we don't have an x minus 3 or an x plus 3, so we include them both in our LCD. Our final LCD is parentheses x minus 2 times parentheses x plus 1 times parentheses x minus 3 times parentheses x plus 3. For example number 4, find the LCD of each pair of polynomials. We have 1 divided by x squared minus 25 and 9 divided by 10 minus 2x. First, we factor the denominators completely. X squared minus 25 factors as a difference of squares. This is parentheses x minus 5 times parentheses x plus 5. For the 10 minus 2x, we could factor out a common factor of negative 2. We get negative 2 times the parentheses x minus 5. From here, we include all of the unique factors from each denominator. Starting with our first fraction, we take x minus 5 and x plus 5 as part of our LCD. From the second fraction, we could take the negative 2 as part of our LCD, and then we already have an x minus 5 in our LCD, so we don't include another one. Our final answer is just the product of all the terms we found for our LCD, which is negative 2 times the parentheses x minus 5 times the parentheses x plus 5. Next, we have a practice problem. Find the LCD of each pair of polynomials. We have 8 divided by x squared minus 49 and 3 divided by 21 minus 3x. Alright, so go ahead and pause the video, find the LCD, and then check back with the video to see the answers. Alright, so let's get started. First, we factor the x squared minus 49 as a difference of squares. We get parentheses x minus 7 times parentheses x plus 7. Next, we factor out a common factor of negative 3 from the 21 minus 3x. We get negative 3 times the parentheses x plus 7. From here, we go ahead and find all the unique factors from each denominator. From the first fraction, we include the x minus 7 and the x plus 7 as part of our LCD. From the second fraction, we include the negative 3. However, we don't include the x plus 7 because we already have an x plus 7 in our LCD. The final answer for the LCD is negative 3 times the parentheses x minus 7 times the parentheses x plus 7. Next, we're going to go over adding or subtracting rational expressions with different denominators. The first step is to find the LCD of the rational expressions. The second step is write each rational expression as an equivalent rational expression whose denominator is the LCD found in step 1. The third step is to add or subtract the numerators and write the result over the common denominator. Step 4. Simplify the resulting rational expression. In example number 5, add or subtract. For part A, we have 5 divided by 6x squared plus 4 divided by 15x. The first step is to find the LCD of the rational expressions. First, we look at the coefficients. We have 6 and 15. We take the larger coefficient 15 and see if 6 divides evenly into 15. 6 does not divide evenly into 15, so we take the next multiple of 15, which is 30. Because 6 divides evenly into 30, we use 30 as part of our LCD. Next, we move on to the x variable. We have x squared and x. We take the x variable with the largest exponent, so x squared is part of our LCD. So the LCD we're going to use is 30x squared. Next, we need to write both fractions as an equivalent fraction with the LCD of 30x squared. Starting with the first fraction, we need to change the 6x squared to 30x squared. To do this, we just multiply that fraction by 5 over 5. For the second fraction, we need to change the 15x to match our LCD of 30x squared. To do this, we just multiply that fraction by 2x over 2x. After doing the multiplication for both fractions, the result is 25 divided by 30x squared plus 8x divided by 30x squared. Next, we combine everything under one fraction. We get our final answer, which is 25 plus 8x divided by 30x squared. Moving on to part B, we have 2x minus 6 divided by x minus 1 minus 4 divided by 1 minus x. First, we need to rewrite the denominator of the second fraction by factoring out a negative from the 1 minus x. The result is 2x minus 6 divided by x minus 1 minus 4 divided by negative parentheses x minus 1. Next, we could simplify the negative in front of the parentheses by combining it together with the negative in front of the second fraction. The result is 2x minus 6 divided by x minus 1 plus 4 divided by x minus 1. From here, we could see that the denominators are the same. Now we could combine everything under one fraction. We get 2x minus 6 plus 4 over x minus 1. Next, we combine like terms on the numerator. Minus 6 plus 4 is negative 2. The result is 2x minus 2 divided by x minus 1. Next, we could factor out a common factor of a 2 from the 2x minus 2. We get 2 times the parentheses, x minus 1, divided by x minus 1. After canceling out the common factors of the x minus 1, we get our final answer, which is 2. Next, we have a practice problem. Add or subtract. For part A, we have 3 divided by 4y cubed plus 7 divided by 18y. For part B, we have 3m minus 26 divided by m minus 6 minus 8 divided by 6 minus m. Alright, so go ahead and pause the video, try out this problem, and then check back with the video to see the solutions. Alright, so let's go ahead and go over part A. The LCD for part A is 36y cubed. Next, we need to change both fractions into an equivalent fraction with the LCD of 36y cubed. We just multiply the first fraction by 9 over 9 and the second fraction by 2y squared over 2y squared. The result is 27 divided by 36y cubed plus 14y squared divided by 36y cubed. Next, we combine everything all under one fraction. We get our final answer, 27 plus 14y squared divided by 36y cubed. Moving on to part B, we first factor out a negative from the 6 minus m, and then we bring down everything else. The result is 3m minus 26 divided by m minus 6 minus 8 divided by negative parentheses m minus 6. Next, we could get rid of the negative in front of the parentheses by combining it together with the negative in front of the second fraction. The result is 3m minus 26 divided by m minus 6 plus 8 divided by m minus 6. Next, we could combine everything under one fraction. We get 3m minus 26 plus 8 divided by m minus 6. Simplifying the numerator, we combine the negative 26 and the plus 8 to get negative 18. The result is 3m minus 18 divided by m minus 6. Next, we could factor out a common factor of 3 from the 3m minus 18. The result is 3 times the parentheses m minus 6 divided by m minus 6. Next, we cancel out the common factors of m minus 6. We get our final answer is just 3. Next, we have example number 6, add or subtract. We have 2x minus 1 divided by 2x squared minus 9x minus 5 plus x plus 3 divided by 6x squared minus x minus 2. First, we need to factor the denominators for both fractions using the star method. The result after factoring is 2x minus 1 divided by parentheses 2x plus 1 times parentheses x minus 5 plus x plus 3 divided by parentheses 3x minus 2 times parentheses 2x plus 1. Next, we need to find the LCD. From the denominator of the first fraction, we use 2x plus 1 and x minus 5 as part of our LCD, and from the second fraction, we only use the 3x minus 2. So our LCD is going to be parentheses 2x plus 1 times parentheses x minus 5 times parentheses 3x minus 2. Next, we need to rewrite both fractions as an equivalent fraction with the LCD as the denominator. For the first fraction, we're only missing the 3x minus 2 from the LCD, so we multiply the first fraction by 3x minus 2 over 3x minus 2. For the second fraction, the denominator is only missing the x minus 5 from the LCD, so we multiply the second fraction by x minus 5 over x minus 5. The result after doing the multiplication for both fractions is parentheses 3x minus 2 times parentheses 2x minus 1 divided by parentheses 3x minus 2 times parentheses 2x plus 1 times parentheses x minus 5 plus parentheses x plus 3 times parentheses x minus 5 divided by parentheses 3x minus 2 times parentheses 2x plus 1 times parentheses x minus 5. Next, we simplify the numerators for both fractions by multiplying the binomials together using FOIL, and then we combine everything together under one fraction. The result is 6x squared minus 3x minus 4x plus 2 plus x squared minus 5x plus 3x minus 15 all over parentheses 3x minus 2 times parentheses 2x plus 1 times parentheses x minus 5. Now we just simplify everything in the numerator. We can combine the 6x squared and the plus x squared to get 7x squared. We combine the minus 3x, the minus 4x, the minus 5x, and the plus 3x to get negative 9x. We also combine the 2 and the negative 15 to get negative 13. The final result is 7x squared minus 9x minus 13 divided by parentheses 3x minus 2 times parentheses 2x plus 1 times parentheses x minus 5. Next, we have a practice problem, add or subtract. We have x plus 1 divided by x squared plus x minus 12 plus 2x minus 1 divided by x squared plus 6x plus 8. Okay, so go ahead and pause the video, take your time working out this problem, and then check back with the video to see the solutions. Alright, so let's get started. First, we need to factor the denominators for both fractions. We could factor both denominators by using the x method. The result after doing all the factoring is x plus 1 divided by parentheses x plus 4 times parentheses x minus 3 plus 2x minus 1 divided by parentheses x plus 4 times parentheses x plus 2. From here, we find the LCD, which is going to be parentheses x plus 4 times parentheses x minus 3 times parentheses x plus 2. Next, we need to rewrite both fractions as an equivalent fraction with the LCD as the denominator. For the first fraction, we're only missing the x plus 2 from the LCD, so we multiply the top and bottom of that fraction by x plus 2. For the second fraction, we're only missing the x minus 3 from the LCD, so we multiply the top and bottom of that second fraction by x minus 3. The result after doing the multiplication is parentheses x plus 2 times parentheses x plus 1 divided by parentheses x plus 2 times parentheses x plus 4 times parentheses x minus 3 plus parentheses 2x minus 1 times parentheses x minus 3 divided by parentheses x plus 2 times parentheses x plus 4 times parentheses x minus 3. The next step is simplifying by multiplying the binomials in both of the numerators and then combining everything under one fraction. The result is x squared plus 2x plus 2 plus 2x squared minus 6x minus x plus 3 all over parentheses x plus 2 times parentheses x plus 4 times parentheses x minus 3. From here we simplify by combining like terms in the numerator. X squared plus 2x squared is 3x squared. X plus 2x minus 6x minus x is minus 4x. 2 plus 3 is 5. So the final result is 3x squared minus 4x plus 5 divided by parentheses x plus 2 times parentheses x plus 4 times parentheses x minus 3. Next, we have example number 7. Perform each indicated operation. We have 7 over x minus 1 plus 10x over x squared minus 1 minus 5 over x plus 1. First, we need to factor the x squared minus 1 as a difference of squares and bring down the rest of the terms. The result is 7 over x minus 1 plus 10x over parentheses x minus 1 times parentheses x plus 1 minus 5 over x plus 1. Next, we need to find the LCD. From the first fraction, we use the x minus 1. From the second fraction, we only take the x plus 1. And the third fraction, we already have an x plus 1, so we don't need to include that. So our LCD is just parentheses x minus 1 times parentheses x plus 1. Next, we need to rewrite each fraction as an equivalent fraction with the LCD as the denominator. For the first fraction, we're missing the x plus 1, so we multiply the top and the bottom by x plus 1. For the second fraction, we don't change anything because the denominator is already the LCD. For the third fraction, we're missing the x minus 1, so we multiply the top and the bottom of the third fraction by x minus 1. The result after doing the multiplication is 7 times the parentheses x plus 1 over parentheses x minus 1 times parentheses x plus 1 plus 10x over parentheses x minus 1 times parentheses x plus 1 minus 5 times the parentheses x minus 1 over parentheses x minus 1 times parentheses x plus 1. Next, we could distribute the 7 inside the parentheses to the x plus 1. We could also distribute the 5 inside the parentheses to the x minus 1, as well as combine everything all together under one fraction. The result is 7x plus 7 plus 10x minus parentheses 5x minus 5 all over parentheses x minus 1 times parentheses x plus 1. Next, I'm going to distribute the negative inside the parentheses to the 5x and the minus 5 and bring down everything else. The result is 7x plus 7 plus 10x minus 5x plus 5 all over parentheses x minus 1 times parentheses x plus 1. From here, we can combine like terms on the numerator. We have 7x plus 10x minus 5x is 12x. We have 7 plus 5 is 12. The result is 12x plus 12 over parentheses x minus 1 times parentheses x plus 1. Next, we factor out a common factor of 12 from the 12x plus 12. The result is 12 times the parentheses x plus 1 over parentheses x minus 1 times parentheses x plus 1. Next, we could cancel out the common factors of the x plus 1. Our final result is 12 over x minus 1. Alright, so we reached the end of our video. Thank you very much for watching. I'm Professor Diwa, and I'll see you in the next one.